Okay, so let's just start with functions. So you know what an equation is. For example, you have an equation y is equals to 2x plus 3. So with respect to the graph, so whatever you have the value of x, it is going to have a respective value of y depending on the value of x. That is going to give you the value of y. Okay? Now, function is, instead of this y, you put the function of x equals 2x plus 3. And talking about the graphing grid, this is what changes in it. So on before you are going to consider the y-axis as f of x and just the x as the x-axis. Okay?
Yes, sir.
Now every function has a domain and a range. Domain stands for domain means so whenever we will be talking about domain of the function, that is basically the value of x. Whatever value we can plug into the function is known as the domain. So in short, the inputs are known as the domains. Okay?
Yes, sir.
And whenever it comes to the range means the output. In terms of equation, the value of y is refers to the range, and in terms of function, whatever the value of after plugging in the value of x, whatever value you get, that is known as the output. For example, if I am plugging in 2 into the function I've written above, so that is going to give us 2 times 2 is 4, 4 plus 3 is 7.
7.
So 2 was my domain, and 7 is the range. Okay?
Yes.
Not every function, so we cannot write every equation as a function. So there are a few equations which are not considered as functions. We'll be talking about it in details later on, but for now, just this was very important in order for to understand the graphs of the quadratics in a better way, especially when it comes to its applications. Okay, now y equals x squared. And that's very basic quadratic, and its graph is going to be like this. You will have a curve on the right, and you will have a curve on the left. So this is known as a parabola. Okay? Now, as it is concaved up means it has an opening upwards, so it is known as upper parabola. You also get a lower parabola whose shape looks like this one. And this one you obtain whenever you have a negative coefficient of x squared. In this case, the coefficient of x squared is 1, and the polarity of it is positive, so that this is going to give us a concaved up parabola. If it's negative x squared, it is going to be concaved down, like this. All right?
Yes, sir.
All right, now I'm going to take you to the different forms of the quadratic equation, and let's just discuss what type. Now, first of all, we'll be discussing about the rough sketches. Now, that's our main topic today, about the rough sketches. Now, about the rough sketch, first of all, you need to understand the main important thing is this one and this one. When are you going to obtain an upper parabola, and when are you going to obtain a lower parabola? So you will always obtain an upper parabola whenever you have a positive coefficient of x squared, and you will always obtain a lower parabola whenever you have a negative coefficient of x squared. All right, now moving on to the full standard form of a quadratic equation, which is y is equals to ax squared plus bx plus c. The other day we studied different formats of the quadratic equations. Now let's just bring one by one, like all of those into over here into consideration, and then we'll see how a graph is going to look like. Now, one of the form is when you factorize. For example, if you have a quadratic equation which is factorizable, then, for example, you get x plus m times x plus n as, like, if you factorize it, so these are the factors which you're going to get. So we'll be discussing each of these, like the perks of each different shape of the quadratic equation. The another possible format is by completing the square, which was x plus p whole squared and then minus q. Okay,
Yes, sir.
so these are the two main things. You will be having another shapes as well, but these are the two main. You should be able to connect every other shape with both of these. Now, for example, uh, let's just say you have x times x plus m. Now, this is same as this one, where you have complete factor form. Okay,
Yes, sir.
the only difference is over here, this factor has a plus m. They're like something is being added into the x of the first factor. Over here, there is also something which is being added into the x of the second factor. Over here, you don't see anything being added into the x of the first factor, but you can rewrite it just for the understanding purpose as x plus 0 times x plus m, so which is eventually going to look like this one. Okay?
Yes, sir.
All right, so I'm going to erase this one because this doesn't matter over here. All right, now the last one, which is also important, x plus m, and then the whole square of it. Just this thing you are going to get if you have a quadratic equation. Upon factorization, you get two special factors which can be written in the index form. Okay,
Yes,
now
sir.
let's just look into the graphical meaning of each of these. Now, first of all, what are we going to look into once we have the graph? Like if you are drawing a rough sketch. So, for example, I have a graphical grid. I have the x-axis and I have the y-axis. Like, I mean, there is no grid behind it. It's just a blank white paper behind the x-axis and the y-axis. Now, what's important over here is, first of all, you need to understand that the is it concaved up or concaved down? Concaved up or concaved down. That we have already discussed. That totally depends on the polarity of the squared term. If the polarity of the squared term is positive, it is going to be concaved up. If it's negative, then it is going to be concaved down. That's the very first thing which we are going to look into. The second important thing over here is the x-intercepts. Like on which points is it going to cut the x-axis? The next one is y-intercepts. And then at the end, we're looking at the turning points. And sometimes tangents. Got it?
Yes,
So
sir.
we'll be extracting all these information from, like, not all of them every time, because every equation has its own shape. So sometimes you may not have x-intercept and y. Oh, sorry, you will always have the y-intercept, but sometimes you may not have x-intercepts, and sometimes you may not have tangents. You will always have a turning point. You will always have the y-intercept. You will always either the graph is going to be concave up or concave down. These okay. Now the things which I have marked with yellow, so those things will always be there. These two things that totally depend on the nature of the equation. So let's just begin with the first one. Now, whenever you have x plus m times x plus n, if you are able to factorize a quadratic expression or quadratic equation like this, then the meaning of this is that this thing over here with the opposite sign and this thing over here with the opposite sign. These two numbers are going to be x intercepts. Means these are the 2 points on the x-axis where the graph is going to cut through. Okay, I forgot one thing: line of symmetry. Okay, so that's going to be there all the time. Line of symmetry will be there all the time. So did you get this part, the first one?
Yes, sir.
All right, let's just do an example for this one. For example, you have the equate or the function as f of x equals to um, x squared and plus 2x plus 8 minus 8. For example, this is the quadratic function you have, and the examiner asks you to find out the if the graph is concave up, find out the y-intercept, turning points, and the line of symmetry. For now, I'm just focusing on uh, this x-intercepts. Now, x-intercept is going to be, like as I stated earlier, we need to look if I will be able to factorize this or not. So this is giving you minus 8x squared. So you need two numbers. When multiply, you should get negative 8x squared, and the difference of the two numbers should give you positive 2x. And the two numbers are positive 4x and negative 2x. Okay?
Yes, sir.
X squared plus 4x minus 2x minus 8. Now I'm going to factorize it further. X plus 4 minus 2 into x plus 4, and then x plus 4 is common, and then x minus 2. So I've got the complete factor form here. Now I'm just going to draw the x-axis because that's what we are focusing on at the moment. I'm not going to focus on the y-axis for now. So on the x-axis, all right, now first of all, just copy these down. This is going to be with the opposite sign. What is it going to be?
-4 and +2.
Yeah, -4 and +2. Now, clearly, which one is smaller from these two?
-4.
So that's going to come on the left, and +2 is going to come on the right. Okay. Now, these are the
Yes.
2 points from where the graph is definitely going to pass through on the x-axis. Okay. The coefficient of x squared is positive, so the graph, this is how the graph is going to be.
Got it, sir.
Cut. Okay. So on the
Yes.
x-axis, the graph is definitely going to cut through these 2 points. All right. And
Yes.
why do we say this? We will be talking about it in a minute. Now, do you remember that when we are solving the equation x squared plus 2x minus a, we have 0 on the right hand side, remember? So if you try linking this 0 with this function, what thing is now 0 over here if you compare it with this one? I want you to compare this and this. What's the difference
Um,
between the two? What is 0 here, which is not over here?
uh, y is 0 there, whereas over there the value of y is not given.
Yeah, so this is f of x means y. Over here, the value of y is 0. Now, if I draw the y-axis here, for example, over here we have the y-axis. So when we say we solve it, so at the end, this is how you do it. X plus 4 times x minus 2 equals to 0. So we see that when y is 0, what is the solution? So we give the solution as x equals -4 and x equals to +2 by applying the zero product property. Okay, now that's what we mean here, that this is the solution to it when we have y as 0, means y-axis on the on the x-axis where the value of y is 0. These are the two roots, -4 and +2. Got it?
Yes.
So for now, the only important thing is to understand that the graph is going to cut through positive 2 and negative 4. Is this clear?
Yes, sir.
All right, now while we are at it, let's just discuss about the line of symmetry as well. Now, for every parabola, there is going to be a vertical line of symmetry like this. So whatever you have on the left, you will always have the same thing on the right. Okay?
Yes,
Whatever
sir.
you have on the left, you will always have the exactly same thing on the right. This doesn't look like exact vertical. Let me just draw a proper vertical line. So, yeah, this one. Okay, now, line of symmetry, when you have this particular format, you can get a line of symmetry by finding out the midpoint of the 2 points where the graph is actually cutting through. That is going to give you the mid of it. Now, what is the midpoint here of negative 4 and 2? Now,
We add the two and then divide it by two.
yes, so negative 4 plus 2 is negative 2. Negative 2 over 2 is negative 1. So basically, the line of symmetry is going to pass through negative 1, isn't it?
Yes.
So that is going to be minus 1. So the vertical line has an equation x equals any constant. Remember? So in this
Yes.
case, if the examiner asks you to write down the equation for the line of symmetry for this particular quadratic function, then it is going to be x equals negative 1. So this is the equation for line of symmetry. Okay?
Yes, sir.
Now, if you look carefully, the turning point of the graph, the turning point of the quadratic, the line of symmetry always passes through that, isn't it?
Yes.
Like, if this is the turning point, the line of symmetry is passing through it. So it means the x coordinate of the turning point you can always get from the line of symmetry. I'm not talking about the y coordinate for now, but let's just stick to the x coordinate for now. Clear?
Yes, sir.
All right. So up to now we've discussed if I'm able to factorize the quadratic function, if I've got two different factors, then by changing the signs for both of them, I will have that. This gives us the information that these are the x-intercepts. The line of symmetry, find the midpoint of the two x-intercepts and write it down as x equals that particular point. And then the line of symmetry always passes through the turning point. So you can have the x coordinate of the turning point from there as well. Okay?
Yes, sir.
All right, now moving on to the same question, same type of question, but a little twisted. For example, it's x times x plus 4. For example, you have a quadratic equation. After you factorize it, this is how the factors turn out. Now, can you write this down as x plus 0? Hmm?
Um.
Just the first factor.
Yes.
Yes, good. So basically, the graph is going to cut at 0 on the x-axis and then minus 4 on the x-axis. This is how the graph is going to be. Okay,
Yes, sir.
great. All right, so this particular format is done. We're done with this. Now moving on to this one, uh, when we have completing square. So, all right, so the other day I told you the discriminant part, which was the b squared minus 4ac. You will always get this type of situation where you will be able to factorize them when b squared minus 4ac would be equals to sorry, would be greater than 0, you will always have real and distinct roots. Roots mean where the graph is cutting the 2 points on the x-axis where y is 0. So these are the 2 points. Okay?
Yes.
Okay. Now, f of x. Now the second situation is f of x equals x plus m and then the whole square of it. Now this is the situation if you talk about the discriminant b squared minus 4ac would be equal to 0, where you would be getting real and repeated roots. Okay? Now in this situation you will not have x-intercepts. Whenever you have an index form, you will not have intercepts. You will always have tangent. You will always have tangent. Means x-axis would be tangent at negative m. Got it?
Yes, sir.
Now, for example, you have the question y equals to x squared um, minus 6x plus 9. Now, if you factorize this, you will get x squared minus 3x plus 9, x minus 3, and then x minus 3 again, x minus 3 times x minus 3, which is x minus 3 whole squared. Okay, now, next thing, I'll be changing the sign of this and I'll rewrite it down as positive 3. Now, again, I'm just going to draw the x-axis over here. Now, here's the x-axis. Now, for example, you have plus 3 here. The graph would be tangent at this point on the x-axis. Like, it's not going to cut through the x-axis. It'll be just the tangent. It'll be touching the x-axis, and the same point would be the turning point as well. Got it?
Yes, sir.
All right. And in this situation, the line of symmetry is also the exactly same thing. The line of symmetry would be x equals 3. And the turning point, the x coordinate is 3 and y coordinate is clearly 0 because it's exactly on the x-axis. Okay?
Yes, sir.
So the line of symmetry is going to be the same point, plus 3. Clear?
Yes, sir.
Should I plot this on the software as well? Is it enough?
No, sir, it's enough.
All right, great. All right, now the next thing is this format over here, which you will obtain by completing a square. Okay, now for example, you have the question as, wait a minute, let me just look for a question. All right, so here I have a question. X squared minus 2x plus 2. F of x equals to this. Now, if I apply a completing square method, it's going to be x minus something else squared minus something else squared plus 2, isn't it?
Yes.
I'm going to put half of the coefficients of x, that's going to be 1 in both cases, and upon simplifying it, I'm going to get x minus 1 whole square minus 1 squared is 1 plus 2, then x minus 1 whole squared plus 1. So that's what I've got. Okay, now before I jump to this question which I've just did, let me just put down the general formula as well. X plus b whole squared minus q. Now this type of question clearly gives you information about two things. One, the turning point, this this thing with the opposite sign, and this thing as it is. So this is the turning point. Okay?
Yes, sir.
All right. Also, talking about the line of symmetry, so that's going to be equals to x equals minus p. That would be the line of symmetry. Okay?
Yes, sir.
All right. Now, coming back to this equation, which we just did. Now, in this case, if I change the sign of this one, that's going to be plus 1. If I copy this down as it is, that's going to be plus 1. Now, that's the turning point for this particular function. Now, for example, I have, it will not give us the information about the x-intercept. Okay? We won't
Yes.
be able to get the information about the x-intercept from here. All right, now for example, we have one here, we have one here. So that's the turning point. Coefficient of x squared is positive, so it's going to go up from this point. Now you can clearly see there are no x-intercepts at all for this particular graph. Now when is this going to happen? If you go back to the previous lesson, talking about the discriminants, let me just recall them. There were three situations. B squared minus 4ac is greater than 0 means you have real and distinct roots. Okay? B squared minus 4ac equals to 0. You have real and repeated roots. If b squared minus 4ac was less than 0, then you have complex roots. Remember?
Yes.
This is the situation where you have no x intercepts of the graph, because the graph is actually not cutting on the x-axis when y is equals to 0. Means whenever the value of when y is 0, there is no way that the graph is actually cutting the x-axis. Okay?
Yes, sir.
So which means you have the complex roots, or in simpler words, there's no solution to it, no real solution. This thing, real and distinct, means you will always have x plus m times x plus n kind of format upon factorization, and you will have 2 points where the graph will cut through the x-axis. And this is the situation where you have x plus m whole square, where the x-axis is going to be tangent at negative m. All right?
Yes.
Clear?
Yes,
All
sir.
right. Now, two things are left. I'm going to go back now. And first of all, I left something in the first part over here. We didn't discuss about the y coordinate of this turning point here. Now you have the x coordinate of this graph where the graph is taking a turn. Okay, now you need the y coordinate of the same point, so you can put x as minus 1 into this equation and get the value of y coordinate into this equation or into the main equation. You will always get the value of y. Okay,
Yes, sir.
so this way you can have a complete turning point. All right. Now, the second important thing is about the y-intercept. You will always have the y-intercept because the nature of the graph is such like it expands. So even if you're going up, or if it's a lower parabola, somewhere along the line, it will definitely intersect the y-axis. Okay, even if it's here on this part of the graph, somewhere down the line, it will definitely cut the y-axis. Okay, so no matter where the graph is, it will always cut the y-axis because it expands and upward and both, like upward as well, and even if it's the lower parabola, it expands downwards as well. So it is definitely going to cut the y-intercept, the y-axis. So we will always have a y-intercept. Now you can get y-intercept in different manners. First of all, if you have the completely expanded form of the equation, this thing at the end is the y-intercept. Okay, this thing would be the y-intercept. Okay,
Yes, sir.
if you have the factor form now, if you want to get the y-intercept, simply multiply these two, multiply the factor. So, all right,
Yes, sir.
and if you have this form like this, take the square of this, you will have the y-intercept form. So this is how you're going to get the y-intercepts. So we're done with all of these. They've seen, we know when the graph is concave up or concave down. We can look for x-intercepts and the tangents. There is always going to be y-intercept. We know how to get that. Turning point is going to be there all the time. We know how to get that. In order to get the turning point, it's always good to, if you're doing the factor form, first of all, you'll have to find out the midpoint. And if you're getting this thing, okay, get the midpoint, and what the x coordinate of the line of symmetry is going to give you the x coordinate of the turning point. And in order to get y, put that particular x into the equation and have the y coordinate of the turning point. And then if you're doing the factor formula, if you've got something like this is actually the x coordinate of the turning point, this one over here. And in order to get, and y is definitely 0 in this case because it is on the x-axis. And if you're doing something like this, where by completing square, where the equation is not factorizable, so x plus p whole squared minus q, then it gives you the direct information about the turning point, which is negative p. Like change the sign of this one and copy this down as it is, and you will have your turning point. And from here, you will have the line of symmetry as well. Clear?
Yes, sir.
Alright, so this was all about it. Now let's just look into the few questions. If you move on to page number, I don't see page numbers here. Do you see page numbers? Nah, I don't. Alright, sketch the graph of y equals 4x. Alright, so that's example number two. Oh, yeah, I see it. 29. 29 of the book. Actually, 28. On question number 28, you have the question as y equals x squared minus 5x plus 4. Find the coordinates of its turning point. And examiner is also asking you to sketch the graph as well. So whenever examiner asks you to sketch the graph, it's very clear. Although examiner is not asking you to find out the x-intercept, y-intercept, but he's asking you to sketch it. Means you need to know the x-intercepts if there are any on y-intercept, and then the additional information he's asking for is the turning points. Okay, so let's just see if we can factorize it. So 4 times 1 is 4, so we're getting 4x squared, and the sum of the two should give you minus 5. So yeah, minus 4 and minus 1. So it's going to be x squared minus 4x minus x plus 4, y equals to x common x minus 4 minus 1 common x minus 4. And then y equals to x minus 4 times x minus 1. Now from here I can clearly tell that x-intercepts are positive 4 and negative 1. So if I draw a rough sketch, just the y-axis and the x-axis as well this time, I'm going to draw both, okay?
Yes, sir.
So that's the y-axis. Here we have the x-axis, and let's just say we have negative 1 over here and positive 4 somewhere over here. It has to be rough, it doesn't have to be exact. Okay, now I know that, okay, now the coefficient of x squared is positive, so it's going to be concaved up. So the graph is going to cut through these 2 points, and this is how it is going to be. Okay?
Yes, sir.
All right, now going back to the main equation, done something wrong. Wait a minute.
Sir, it's +1, not -1.
Where?
Because in the like the after you factorize
Ah,
it.
yeah, yeah, yeah. Yes, both of them are positive. I forgot to change the sign. Positive one. So positive one is going to be over here. Okay, I would like to share how did I learn that I did something wrong. The y-intercept is +4, and the grammar in my case, which I drew earlier, the y-intercept was coming negative. Okay, so that's
Yes.
how I realized that I made a mistake. All right, so now the graph is going to go through these 2 points in this way. So this is how it is going to be. Now the y-intercept is over here. Just copy this down. Is +4. Okay. Now the turning point for this one is going to be, just simply look for the midpoint of it, or you can rearrange the equation into the completing square format, whatever method you feel is good for you. So if I do it by finding out the midpoint of it, so that's going to be 2.5, isn't it? 1 plus 4 is 5, and then divided by 2, that's going to give us 2.5 up here. So that the x coordinate is 2.5, and in order to calculate y, I'm going to put 2.5 into this equation. So y equals 2.5 squared minus 5 into 2.5 plus 4. So put this in the calculator. 2.5 squared minus 5 times 2.5 plus 4, and that is negative 2.25. So the y coordinate for this one is negative 2.25. Okay.
Yes, sir.
All right. So this is how you're going to do it. Or if you want to do it by the completing square, then you will be rewriting the same equation as y equals x minus 5 by 2 whole squared minus 5 by 2 whole squared, and then plus 4, which is going to give us x minus 5 by 2 whole squared minus 25 by 4 plus 4. And 4 times 4 is 16, plus 16 minus 25 is minus 9. So x minus 5 by 2 whole squared minus 9 by 4. So the turning point is positive 5 by 2 and negative 9 by 4. Okay?
Yes, sir.
All right. So whatever method you are comfortable with, you can use both of them. Okay? All right. Now,
Yes.
question number 2 is sketch the graph of the example number 2. Sketch the graph of y equals 4x minus 2x squared minus 3. So let's just rearrange the equation. Minus 2x squared plus 4x minus 3. Now clearly this graph is going to be a lower parabola. Okay, now the question is find the coordinates of its turning point and write down the equation of its line of symmetry. Now we need to do the turning point. Once we have the turning point, line of symmetry is going to be the piece of cake. Just simply x equals to the x coordinate of the turning point. Okay?
Yes.
All right, so the turning point thing. Okay, let's just do it. Are we supposed to sketch it as well? Yeah, sketch the graph of this. All right, let's just see if we can factorize it. So minus 2 times minus 3 is plus 6x squared. So we need the two numbers. When multiplied, you get plus 6x squared. And then the sum of them. Why sum of them in this case? Yeah, sum of them should give you 4. product should be 6 and the sum should be 4. Can you think of the numbers?
Um,
2 times 3 is 6, that's it. That's not 4, that's 5. So I'm not able to factorize it, so let's just not do it then. All right, so we are not able to factorize this, so directly apply the completing square then. So I'll take minus 2 as common because the first thing about completing square is that coefficient of x squared should be 1. Now that's going to leave us with x squared minus 2x plus 3 by 2. Clear? So take a negative sign and 2 as common from the entire function. Now y equals to minus 2 x minus 1 whole squared minus 1 whole squared plus 3 by 2. Y equals minus 2 x minus 1 whole squared minus 1 plus 3 by 2. And that's going to leave us with x minus 1 whole squared plus 1 by 2. And then multiply the negative 2 inside. That's going to give us negative 2 into x minus 1 whole squared minus 2 times half is going to be negative 1. Okay? All right,
yes,
now
sir.
the turning point in this case would be positive 1, and this one as it is, negative 1. Now if I draw the y-axis and the x-axis, and let's say positive 1, yeah, positive 1 is going to be over here, negative 1 is going to be over here, so the turning point would be here. And having said that the coefficient of x squared was negative, so it is going to be lower parabola from here. So there is no way it is going to have roots, real roots. Okay, so it's not going to have x-intercepts or the tangent thing, nothing.
Got it, sir.
Now the y-intercept would be negative 3. If you look up here,
Yes.
okay, it's going to be negative 3, and the turning point is 1 and minus 1. Now the line of symmetry is also over here. So the equation for this one is going to be x equals 1. That's it. This is all you were supposed to do in this one.
Got it, sir.
All right, great. So I would like you to do a few questions from here now. All right, let's just do one question. I was looking, wait a minute. Let me look for a difficult one. Okay, first of all, can you go to where the page number written? Page 33. 32. Page 32, question number 2. It says x squared plus 6x plus k equals 0. It should have 2 real roots. You need to find out the value of k. 2 real roots. 2 means distinct, okay?
Yes.
All right, now means b squared minus 4ac should be greater than 0. So 6 squared minus 4a and c should be greater than 0. We're finding out the value of k from here. So 6 squared is 36, greater than 4k, and 36 divided by 9, and 4. So k is basically less than 4. Find the values of k for which this
So why
equation.
is it 36 divided by 9 instead of 4?
Sorry. My bad. I'm really sorry. I had it 9 before the division, so I put that there. Ah, 9. So k should be less than 9.
9.
Got it?
Yes.
And exactly the same way, find the value of t for which it had exactly one solution. Again, the discriminant part, b squared minus 4ac should be equals to 0
Equals
in
to
this case. All right, has equal roots. Find the yeah. Find okay. Given that function has equal roots, find the value of the positive constant s. Exactly in the same manner. Find the range. Okay, we haven't done the range part. I'll tell you that later. The function this where p is an integer has two equal roots. All right. Now move on to page number 33. Looking for harder questions. You should be able to do all of these. All right, page number 34. Question number 11. All right, it says a diver launches herself off a springboard. The height of the diver in meters above the pool, t seconds after the launch can be modeled by the following function. So the height with respect to time is 5t minus 10t squared plus 10. And definitely t is not negative. T is the time in this case, so it can never be negative. So that's why it says that t is greater than or equals to 0. Okay?
Yes.
Now the first part is how high is the springboard above the water? All right. If you want to calculate the height of the springboard, what are you doing? Now, what things do we have here? We have the time and we have height with respect height of the diver. Okay, that's what it says up there. The height of the diver in the first line. Okay, that's not the height of
Yes.
the springboard. It said height of the diver with respect to the time. So what should I do here in order to calculate the height of the board?
The height of the board should be the amount of time it took like the diver to like get to the pool and like in respect to the height.
Sorry, I couldn't get you. Come again.
Uh, the height of the springboard should be that like the amount of time it took the diver to reach the pool times their height.
Okay, maybe any other shorter method.
I'm a little confused here.
Okay, if you put okay now that's the board here. Let's just say this is a swimming pool down here. The diver standing up here. Now the equation is giving us the height of the diver and the time taken by the diver. Definitely, this is how the diver is going to jump. It's going to give us the parabola, isn't it?
Yes.
Okay. Now the height of the diver is same as the height of the board before you take a jump, isn't it?
Yes.
So time would be 0 in order to calculate the height of the board. The time hasn't started yet, so this function is giving you. Are you understanding my point?
Yes.
All right, it's
Kind
saying
of.
that a diver launches herself off a springboard. That's the first information. They say the height of the diver above the pool, like above the pool, that's the height of the diver. Okay?
Yes.
T seconds after the launch, like once the diver launches himself, can be modeled by the following function. When the diver hasn't launched himself yet, so what's the time at that? So they haven't started with stopwatch, isn't it? The time
Yes.
is 0. So if you put t equals to 0, so basically in short, you need to do h of 0. So that's going to be 0 minus 0 plus 10. So height is 10 meters. Okay?
Yes.
Right, the next part of the question is use the model to find the time at which the diver hits the water. All right, and when the diver is hitting the water, we need to find time. What's the height above the water at this time?
10.
No. When the diver reaches here,
The height is 0.
yes, the height is going to be 0. So
Yes.
it means I'm going to put 0 in place of h of t. So y is 0 in this case. That's going to give us 0 equals 5t minus 10t squared plus 10. So technically, I'll be solving this quadratic equation. So if I rearrange it, it's going to give me 10t squared minus 5t minus 10 equals 0. 100 squared, and the difference should give us 5. Negative 5. No, not possible. All right, let's just use the quadratic formula instead. So it's going to be t equals b squared minus 4a c root of it, and then whole divided by 2a. T equals 25 minus, what do you get from it? Plus 400? Oh, no. Sorry, I wrote the formula wrong. B squared minus 4ac. 25 plus 400. That's what you get. Over 20. So let's just put this in the calculator and get to the solution directly. So A is 10, B is minus 5, C is minus 10. So one of the solution is minus 0.781 seconds, and the other solution is 1.281 seconds. So which one of them is going to be right?
The positive one.
Yeah, so it'll be, this is the time. So after this time, the height is going to be 0. So basically, this is the time when he's about to get into the swimming pool. That's what the question was, isn't it? Use the model to find the time at which the diver hits the water. Yeah, perfect. So 1.281 seconds or 1.28 seconds. Okay?
Yes, sir.
Now he's saying rearrange the formula, h of t in the formula, like completing square. All right, completing square method. 10t squared. Okay, h of t equals 5t minus 10t squared plus 10. I'm going to rearrange it as negative 10t squared plus 5t plus 10. So I've brought the squared term first. Okay, now what I'm going to take common from here.
You can take
Like
5.
10. I need to make this coefficient of squared term as 1.
Yes, negative 10 then.
Negative 10. So it's going to be t squared. T squared minus 1 by 2 t and minus 1, isn't it?
Yes.
Okay. H of t equals negative 10 t minus something squared and then minus 1. Half of 1 by 2 is going to be 1 by 4, and negative 10 t minus 1 by 4, and then the whole square of it, minus 1 by 16, and then minus 1, and that is t minus 1 by 4 whole squared minus 17 over 16. Multiply 10 inside, so negative 10 t minus 1 by 4 whole squared minus minus is plus 10 times 17 over 16. So 170 over 16 is 85 over 8. All right, so we've done it. So 85 over 8 minus 10 into t minus 1 by 4, and then the whole square of it. Now a is 85 over 8, which can be written as 10.65. And b is, examiners use minus b, so I'm just going to copy it down as it is. And c is just 1 by 4, which is 0.25. All right, well, the next part is using your answer to part C or otherwise, find the maximum height of the diver at the time at which his maximum, find the maximum height of the diver at the time. Find the maximum height of the diver and the time. All right, we need to do two things here. And the time at which this maximum height is reached. Okay, so we need to find the maximum height. So in short, we need to look for the maximum value of this function. We need to find, this is height. What would be, when are we going to get the maximum value of this? We'll be getting the maximum value of this when this thing is 0. When would this thing be 0? When t is equals to 1 by 4. Isn't it?
Yes.
So in short, okay, now that's the practical. I'm trying to explain you in practical terms. Explain you in mathematical terms as well. This is the height. We need to find the maximum height. This would be maximum if this whole thing is gone. Because you see, whatever we have is being subtracted from this one. So I need to get rid of this. Means I need this as
Yes.
0. This could be 0 if I have plus 1 by 4 here. Isn't it?
Yes.
So if I have plus 1 by 4 here, this thing is gone. So basically, at time at 1 by 4 seconds, I will reach the maximum height, which is 85 by 8. Isn't it?
Yes.
Okay, now I'm going to explain you through the mathematical term. This is how the graph of the diver would be. This is the maximum height. This maximum height, on the x-axis I have time basically, and on the y-axis I have the height. The turning point is this thing with the opposite sign, which is 1 by 4. And the y-coordinate, which is height, is 85 by 8. You see, how do I know I have time on the x-axis? Look, it's h of time. On the x-axis, I have time. On the y-axis, it's h of t, like height with respect to time. Okay?
Yes.
So, at t equals 1 by 4, as in 0.25 seconds, the diver will have its maximum height, and that would be as 10.625 meters. Okay,
Yes, sir.
clear?
Yes.
Okay, that's all about it. Any questions?
No, sir. No questions.
Chalo. Go through this entire lesson one more time, and if you have time, you can go through the recording. You can always play the recordings and change the playback speed to 2x. Just do